so chapter 1 is a fraction review. That's something that most people forget no matter what math class they're in. And some people try to avoid it as much as they can. That's not going to help you. It's going to make it worse. So let's just get over with and review, figure it out. So the hardest ones are to add and subtract fractions. In order to do so, you need to find the LCD. So before we do any actual work, let's find the LCD of the following: 5/6, 2/3, and 3/4. So 5/6, 2/3, 3/4. So LCD stands for least common denominator, right? So what you're actually looking for is the least common multiple of 6, 3, and 4. So I'm going to show you the way that always works, even if they're not numbers. The easy way to do it that most people prefer is to think of a number that they all divide into, but that only really works for numbers. Once you get to stuff where it's no longer numbers or the number is really huge, then it gets difficult. So what I recommend is take each denominator and factor it into prime numbers. Now, if it's already prime, well, it's already prime, right? 4 is 2 times 2. So do you agree that all of these are factored into prime numbers?
Yeah. Right.
Yeah, right. You can't go any further. So if you can't go any further, you can't break it down anymore, then for sure. Right. So the way you find the LCD, you just go through each number. So let's start with the lowest number, 2. There's 2 2s right here. There's no 2s there. There's 1 2 here. So you write the most number that appeared. So there's 2 of them. Right. Or you can write it like this if you want. So now we go to the next number, 3. There's no 3s on this one. There's 1 3 here, 1 3 here. So at most, we only saw 1 3 in either factored number, right? Do you understand where these numbers came from?
Yes.
If that's clear, then you already found the LCD. So this is simply 2 times 2 is 4, times 3 is 12. So 12 is the number that all of these divide into. Is there any questions on finding LCD? Is that okay? Let's do another one with bigger numbers, just in case. Find the LCD of 720, 1130, and 2/15. Okay, so if you can break it all right away in your head, then just do piece by piece. We know that 6 times 5 is 30, right? So now break the 6 down into 2 times 3 times 5. So you can do it in a couple of steps just to be safe. You could have picked 3 times 10 or 2 times 15, it doesn't matter. Eventually you'll get to these 3 numbers. Okay. Now let's do 20. That is 4 times 5, which is 2 times 2 times 5. Now we take the 15. That That's 3 times 5. So that's all. There's nothing else to do for that one. I wrote it twice just so it can be all right next to each other. There's no reason for this. It's me being weird. So LCD. The same process. Start with the lowest number. 2, right? There's 2 2s here, 1 2 there, 0 2s here. So at most we have 2 of them in one spot. Now I go to the 3. There's 1 3, 1 3, 0 3s. So only 1 at most. 5 5 5 5. Any questions on where these numbers came from?
No, sir.
So then that will be what? What is 2 times 2 times 3 times 5?
60?
Yeah, it looks like 60 to me too. Okay, so LCD is 60. So all these numbers will divide into 60. And it is the smallest, the least common among all 3 factors. Okay, so these steps must be done before you add fractions. So now let's go back and actually add things. So this is the actual first example from your workbook. I added 2 extra ones just to remind you and what LCD means. Let's add that now. So 5 6 minus 2/3 plus 3/4. So we already did the LCD. We said the LCD of all 3 was 12. Right?
Yes.
So we got to change all of these denominators into 12. You can just multiply by the number that you think in your head, or you can look at the factors and see what's missing. 6 needs, in order to become 2 times 2 times 3, right? The 6 needs 1 more 2, correct? So you will multiply here by 2 over 2. The 3 needs a 2 and a 3 in order to become 12. Or you can just say 4 times 4. However you want to think about it, I don't really care. I just want you to know, I just want you to change these numbers into the LCD. So let's go ahead and start doing that. So take the 5 6, multiply by 2 over 2, minus 2/3, multiply by 4 over 4, plus 3/4, multiply by 3 over 3. So I introduced all these guys here. Since it's a form of 1, I'm not actually changing anything, right? So multiply and then you'll have your LCDs. Any questions on this step? This okay? Okay. So this would be 10/12 minus, so 2 times 5 is 10, 2 times 6 is 12. That's what I wanted. 4 times 2 is 8. 3 times 4 is 12. 3 times 3 is 9. 3 times 4 is 12. So all this was just to get 12s. Now that they have the same denominator, you can just add the numerators, right? So the same thing is, all you got to do is do 10 minus 8 plus 9. So what ends up happening is you take all these pieces and put them over 12. And if you think that's weird, you can just do it one at a time. That's fine too. You could say 10 minus 8. So an alternate method. 2 over 12 plus 9 over 12. I combine these two first. You get this. And then add the 9, which would be 11. So that's one way to do it. I don't care how you do it, just make sure you do it correctly. That's all that matters. So, or you can do it all at once. 10 minus 8 is 2, plus 9 is 11 over 12. So if you want to go this way, that's fine. You want to just combine them into one fraction, that's cool too. Is there any questions on adding fractions or subtracting?
No, sir.
Okay, so that's all you need, right? You just gotta get the LCD, change them into that LCD, and then you're good. Just add the top part. Let's do one more, and then we'll move on to multiplying. You guys cool on this page? No questions at all?
No, sir.
If you missed something, or you want me to leave it there for a moment, let me know. I'll turn it back. Print the page back if you need me to. So now let's do the other one. 7 over 20 plus 11 over 30 minus 2 over 15. So what should I multiply the first fraction? Because we said that the LCD was 60, correct?
Yeah, you would multiply by 3.
Yeah, this one needs a 3, right? 7 over 20 times 3 over 3. Now what about the 11 over 30
By 2.
by 2? And the 2/15.
By 4.
Yeah, 4. This will make them all into denominators of 60. Are there any questions on this step here? 7 times 3. 11 times 2. They're all going to be 60, right? 2 times 30, 20 times 3, 4 times 2. So now they're all in the common denominator. So just combine the numerators. 21 plus 22. This time I'll just do it piece by piece. That will be 43, right? And that 8's still here. 43 minus 8, that will be 35, right?
And then after that, can you actually drop the fraction even more down?
Yeah, at this point we should reduce. The other one was prime, had a prime number on top. There was nothing we can do, but here you can reduce. What I
Okay.
recommend for you to do is break it into prime numbers. That way you know for sure that it's been reduced all the way. So look at 35. We know that's going to be what? 5 times 7, right? And 5 goes into 60, what? 12 times?
Yeah.
So now that it's factored, we can cancel the 5s because it's a common factor, or you can think of it as division. 5 divided by 5 is a 1. So 1 times 7/12 is 7/12. This will be our final answer. So the reducing this way will be helpful when we start the next step, which is multiplying. Because I don't recommend you multiply anything until you've canceled and factored. That way you'll be good. You won't have to reduce at the end if you reduce at the beginning. You guys cool on adding and subtracting or LCD? Those ideas make sense?
Yeah,
Yes, sir.
If there's any issue, let me know. Multiplying fractions. So when you multiply, what I recommend you do is just put them next to each other. Do 16 times 3, but don't actually multiply. 7 times 8. So at this point, you can start reducing. If you're comfortable dividing in your head, just say, oh, 16 divided by 8 is 2, that's cool. But what you can just simply do is break it down to factors. 2 times 8 is 16 over 7 times 8. So these 8s will be gone. And since I did it this way, I know for a fact that at the very end, it's already reduced. We don't have to worry about it. If you just multiply it like straight up and don't do this, then you're going to have a very large number, and then you're going to have to reduce later. Sometimes it doesn't matter. Most of the time it doesn't matter, but when these numbers get huge and you have like 10, like let's say 1,500, whatever. If it's really large, reducing and breaking it up is annoying. So it's better to break it up when they're small before you've multiplied. And it's nice to not have to worry about it when you're done. Any questions on number 5? Remember that when you're multiplying, you don't worry about LCD. That doesn't come up. That is only for adding or subtracting. Here you just put them together, reduce them, and you're good. Multiply. Straight across. All right, so this next one, let's do the same thing. You have 22 times 5 over 45 times 11, right? These two fractions multiply across. So again, I'm just going to put them right next to each other. So I can see that 22 is 2 times 11, right? 45 will factor into 9 times 5. So at this point, you cancel your factors. And I didn't really have to multiply anything, right?
no,
And we know for a fact that this is already reduced. Is there any questions on multiplying?
I just have a question. So pretty much for multiplying fractions, you just try to find the top, the numerator.
Yeah, you just multiply them, right? You just put them together like this, top and bottom. And then you break them down as much as you can, or until you see a common factor and cancel them.
All right, yes, sir, I got it.
Whatever's left, you may have to multiply. But if there's nothing left, then you just write what's there.
Yes, sir.
All right, and let's do division. Division will be almost the same. There's just one extra step. So multiplying and division are really very similar. You guys cool on this page before I turn it?
yes, sir.
Just let me know. I mean, there's no rush. I'll also be scanning these after class and sending them to you.
Well, thanks. I've been screenshotting it this whole time, so.
Yeah, I'll send a PDF and I'll be uploading the video right after, a little bit after class ends. Okay. So dividing fractions. Number 7, example 7. So here we have 6/5. Oops, a little dyslexic there. 6/5 divided by 4/7. So you have a fraction divided by a fraction. So it's all you have to do is flip the one you're dividing by and then multiply. So you actually change it into a multiplication problem. So you keep the first one the same and flip over, take the reciprocal of the one you're dividing by. And then you just follow the multiplication rules. So back to the last example. That'll be 6 times 7 over 5 times 4. Reduce 2 times 3 times 7. 5 times 2 times 2. So all I see is a 2. So now I will go ahead and multiply, and it's already reduced. Are there any questions on number 7?
I don't
Wait,
necessarily. Oh, go ahead. Sorry.
oh, I'm sorry.
No, it's
What
okay.
was
You can.
were you gonna use the second 2 on the denominator?
Oh yeah, good point, good catch. 5 times 2 is actually 10, isn't it?
Yeah.
Thanks.
Mhm.
Okay, I don't necessarily have a question, but can you just do another question? Because I got lost. Okay.
Yeah, well, actually, let's redo this one, but with a different notation. There's something I want you to see. If you see division written this way, it's the same as this symbol. 6/5 divided by 4/7. 6/5 divided by 4/7. So what you would do is to keep the top one the same and then flip over the bottom one. And then start doing the same process, right? So then we go multiply the numerators together, the denominators together, break down the 6 into prime numbers, break down the 4 into prime numbers. 2 times 2 is 4, 2 times 3 is 6. And then you cancel anything that is the same on top and bottom. And that's how we got 21/10. 3 times 7, 5 times 2. So if you see it written this way or that way, please know that it's the same thing. This is my alternate example there. Let's do one more. Division type. So 3/14 divided by 7/8. So The rule says you just flip over the first one or the second fraction and then multiply. So this will give us, you'd never change the first one. 8/7. And then begin your multiplication rules. That will be 3 times 8 over 14 times 7. Factor the 8 into 2 times 4. Factor the 14 into 2 times 7. Cancel the 2's. Multiply what's left over. 3 times 4. 7 times 7. And since nothing cancels here anymore, there will be no more reducing. Any questions on 7 or 8?
No.
Okay, so let me show you something really quick. This is in your, I assume you have your PDF open, but if you don't, page 2 has all the steps to use a calculator, so you can add these up and stuff. But I don't know if you have the 30XS. We do check them out starting, I think, next week. If you want to get one, we'll figure it out. They're also like 10 or 15 bucks, so it's whatever you want to do. But anyway, this will allow you to check all your work from these examples that we just did. All right, let's move on to sign numbers on page 3. So let's read the first part together. Page 3 says, if the numbers have the same signs, you just add their absolute values. And then you just keep the sign. Use the common sign in the answer. So what that means is if they're both negative, you just add them together as if they were positive. 5 plus 8 is 13, and you just keep the sign. You see what I'm saying?
But if the bigger number was a positive, wouldn't it have turned into a positive?
Yeah, that would be case 2. That's when things change. But if they're the same signs, you don't have to worry about anything. You just add them up and then put the symbol that they both had. If they're both positive, obviously you keep it positive, right? If this was 5 plus 8, you would keep it as a positive 13. Negative 5 plus a negative 8 is a negative 13. Same thing as if it were 5 minus 8, still negative 13. Okay, so we'll do this in a second. Case 2, if the numbers have different signs, subtract their absolute values and use the sign of the number with the larger absolute value. So that's what you were talking about. So the bigger one is 12. So 12 minus 2 is 10. So you keep the sign of the biggest one. So since this one, the positive was bigger, you keep this one positive. Okay. 7 minus 4 is 3, and you keep the sign of the bigger one, so minus 3. Or negative 7 plus 4 is 3. However you want to think about it. That's what case 2 is telling you to do. Okay. Does that make sense?
Yes, sir.
So let's work them out real quick. So -5 plus a -8. So all that means is you have to, you just add them up as if they were positive. 5 plus 8 is 13. And since they're both negative, you keep it negative. This would be the same as saying -5 minus 8. You add them together and you keep it negative because they're both negative. These two are the same question. You can think of this one in terms of money. This is like I'm adding debt. This one is I'm taking it away, taking money away. So it's the same thing, right? I'm adding negatives to my bank account or I'm withdrawing $8. That is the same thing. Any questions? Does that make sense? Number one. So here, as soon as you see a minus, just think the easiest way to do it in your head. Just say, all right, 7 minus 4 is 3. I don't even think about it. But then you go back and say, okay, which one was bigger? 7 was bigger, so I keep that sign. That's one way you can do this. If you want to make it a little easier on yourself, that is totally fine. Now, let's say we had written it this way, right? 4 minus 7. Same, this is the exact same question. You would say, oh, that's 3, but you keep the sign of the bigger one. Does that make sense?
Yes, sir.
Okay. Go ahead. We'll move on to subtraction then. Okay, so this is example 5. I'm going to skip 3 and 4. So same deal here. So -3 minus 6. They are both negative. So add them together. 3 plus 6 is 9. Keep it negative. Five minus 8, what is that going to be? Positive or negative?
Wouldn't it be -13?
See, if they're different, you just subtract it. 5 minus 8 or 8 minus 5 is 3, and you keep the sign of the bigger one. If they were both negative, then it would be -13. If I write it the other way, does it make more sense? -8 plus 5, or does that make less sense?
Nah, that makes better sense.
So -8 plus 5, -3. Same question. So whenever you see signs that are different, just subtract it. Just pretend you're doing a basic subtraction problem, 5 minus 8 minus 5 or whatever. Put the solution and then keep the sign of the bigger one. Now you can also do number lines if you like. For people who struggle a lot with the signs, the first thing I ask them to do is start with a number line. Let's do this one. It's a little smaller. So if I have -3, right? So there's 0. -1, -2, -3. If I subtract 6 more, I gotta go 1, 2, 3, 4, 5, 6 in this direction. So -4, -5, -6, -7, -8, -9. Right? So -3 minus 6 means go in that direction. So whenever you're struggling or you doubt yourself, you can always draw a number line and check. This is where you start. This is where you move. Right? Excuse me. All right, let's move on to multiplication, unless you guys have any questions on adding or on the signs of adding and subtracting. Is it okay? All right, let's move on then. So let me know. So multiplying and dividing. So if the signs are the same, they will always be positive. That one's the easiest to remember. If they're both negative, plus. If they're both plus, obviously they're plus, right? So let's see here. The same thing for division and multiplication have the same rules. So if you divide two negatives, positive. If you divide, if they're different in any way, if one is plus and the other one's minus, it will always be negative. Okay. They don't have the plus plus version because that one should be a given. Okay, so look at these guys, both negative, therefore positive, right? One is negative here, so the answer will be negative. For division, one of them is negative, so the answer will be negative. If they're both negative and you're dividing, same rule, positive. An important note is example 13. You see how they don't have a parentheses? And this one does. So if you see it written this way, you're going to assume that there is no parentheses and they have a -2 times 2 times 2 times 2. If you see it in the parentheses, that means you're going to multiply the entire thing 4 times. Does that make sense? Do you see the difference? So on number 14, let's go ahead and do those two real quick. So -2 to the 4th equal to -2 times 2 times 2 times 2. So -2 times 2 is going to be -4, right? 2 times 2 is a +4. -4 times -4 is a -16. Does that make sense? Okay, I'm assuming you guys are good. You have some, you remember some of your basics. If not, let me know. -2 to the 4th. We said that means you got to do the entire thing 4 times, right? So negative times negative is, we agreed, is going to be positive. Negative times negative again is the same thing. So now 4 times 4 is 16. So when you have an even number of negatives, it's going to be positive because of this right here. This will always happen. Is there any questions on the signs for multiplying and dividing?
No, sir.
Just let me know. I'll move on to order of operations, the PEMDAS and all that stuff. If the signs are okay. So review of order of operations. So parentheses, simplifying expressions inside of parentheses or grouping symbols. So these will always have priority. These go first. P. E, exponents, including square roots, go second. 3, multiplication or division, that as they appear from left to right. Addition or subtraction as they appear from left to right. Also called, please excuse my dear Aunt Sally, right? PEMDAS. So let's do number 1 together. Okay, so 45 divided by 3 squared times the square root 25 plus 3 times 7 squared. These are those weird questions that pop up on like social media or something, like nobody can solve this. Everybody gets like 7 different answers. Have you seen those?
Yes, and it's very annoying with all the different answers.
Yeah, people are just arguing over dumb stuff.
People swear they got the right answer.
Yeah, I mean, the reason they're arguing is because the problem itself is just poorly written. And the other part is not everybody remembers PEMDAS. So let's go over it real quick. Most of those questions can be better written by just adding some parentheses or being more clear or staying away from division symbols, stuff like that. Make it easier to read. But anyway, so left to right is what we said. So do we see any parentheses on this?
What wouldn't it be the square root 25?
Yeah, square root looks like it's going to have priority because it's somewhat a parentheses, but it's also an exponent. So that one I think is going to go first. So we will do exponents first. Okay, so anything with an exponent will be done on this step. So what is 3 squared?
Is it 3 times 3?
Yeah, 3 times 3, right? So that'll be that guy, square root of 25. We'll do that one next. So it's same, right? And then this has an exponent. So 21, actually, my bad, 49. So in this step, we did all the exponents. Okay, so now we do multiplication or division. So multiplying and division all have the same level of priority. So they're about the same, right? One does not go before the other. They do go before adding and subtracting. So starting from the left to the right, begin dividing or multiplying, right? So the first thing that I see is 45 divided by 9, right? That's first because I'm starting left to right. So what is 45 divided by 9?
And then at 5.
Yeah, that's going to be 5, right? That 5 is still there, so I'm going to put it right here. I'm not doing plus yet. So the next thing that I see that's multiplying or dividing is 3 times 49. Yeah, what's 3 times 49? It's kind of 1 something.
Would it be like 147?
Yeah, 147. Okay, so now let's multiply that last one. We have 25 plus 147. There's no more multiplying. So at the very end, you add or subtract whatever's left over. That's going to be 172. Any questions about this? Okay, let's see. Let's find another one here. This one looks annoying, but I guess we could do it. Zero 0.7 minus 0.2. Actually, there's no parentheses there. 0.7 minus 0.2 times the bracket. 11 minus 3. Close parentheses squared. Okay, that looks pretty nasty. Divided by negative 1.3 minus 0.5. So let's deal with stuff in parentheses, right? Looks like, and you should always start with the innermost parentheses. Notice how I have a parentheses here, right? And then one inside. So we got to start with this parentheses first. So 11 minus 3 is going to be right here. That will be 8, right? Now let's deal with this parentheses times 0.2. What is 0.2 times 8?
Wouldn't it be 0.16?
Yeah. So it'll be negative 1/6, right? Squared. So now I've dealt with the innermost, so those are done. Now, deal with these sets of parentheses. So 0.7 minus 1.6. What's that going to be?
Wouldn't it be 0.9?
Yeah, but we're going to keep the sign of the bigger one, right? Negative 0.9. Negative 1.3 minus 0.5. Just add them together and keep the sign. That'll
Wouldn't it
be-
be negative 1.8?
Yeah. Okay. Now you got to deal with the exponent. Negative 0.9 squared. What's that going to be?
Wouldn't it be 8.1?
8 point. No, 0.81. It's close. Positive though, right? Divided by negative 1.8. Almost done with this problem here. So left to right, multiply and divide, because we've done all the stuff inside parentheses. We've done the exponents. There's not much left to do. So 6 times 0.18. That's going to be 4.86 divided by negative 1.8. Now this is a plus and that's a negative, so the answer will be negative. So at this point, I'm going to be lazy and use my calculator because I don't want to deal with this. But anyway, the main idea is, do you see how the order of operation works? What goes first, second, etc. Now, if you were to plug it into the calculator I was talking about, if you plug in exactly how it's written here, it'll come right out as negative 2.7. Because the calculator has been programmed to know PEMDAS, so it knows the order automatically, as long as you type it in correctly. So these next few problems are just to practice with the calculator, just so you can find out how to use it and understand where the parentheses go and exponents and all that stuff. So if you have one, I'd recommend just going through these on your own. Let's see here. Page 6, by the way. All right, let's look at let's move on to chapter 1, algebraic expression. So at this point, the review is ending. So now we're getting to the algebra stuff. I think when you start your homework, you're going to see more of this type of stuff, not the review stuff. But I think the review is always good, just in case you have become rusty. And if you have any issues or you forget something, please let me know. I'll help you out. So let's just go through this together, because I think we're almost out of time here. Let me see. Yeah, 15 minutes left or so. So in this guy, they're asking us to determine how many terms there are. But first you need to know what is a term. Right, obviously I can't answer the question unless I know what a term is. So definition of a term is basically any number or algebraic expression that is separated by a plus or a minus. So this is some expression separated by a plus and another one separated by that same plus. So here we have two terms. That makes sense? So here we have how many terms? What do you guys think?
Oh, we got two.
So we got 3x squared separated by minus, and then 6xy separated by plus 5. So all three of these are terms. So 1, 2, 3. So as long as we see a plus or a minus in between something, that's going to be a term. So check these out. We have this fraction, negative fraction, plus some other fraction minus another fraction. So we got 1, 2, 3 terms. Does that make sense?
So the terms are just the signs.
Kind of. It's an expression that's separated by a plus or a minus. So you see how this has a so this right here is one term. This is one term. This is another term here. So 1, 2, 3. What do you guys think about this one? How many terms is that?
Wouldn't that be like maybe 4? I'm thinking.
It looks like it could be, right? But it's kind of a trick question. There is no pluses or minuses in between, right? Because the pluses and minuses determine whether you have another term. So this is actually just one term because there is no symbols in between the numbers and letters. Like 3x squared is one term because there's no plus in between. So if this was 3 plus x squared, that would be 2 terms. Does that make sense?
Yeah, okay, I got it. I understand.
So 6xy is a single term, it's not 3 terms. 5 is a single term. Okay. Any questions on what a term is before we move on to 3 and 4? Okay, sorry about that. Let's do one of these and we'll call it a day. I'll let you get to your homework or whatever you got else, whatever else you got going on. So f is equal to 9/5 c plus 32. So what this does, actually, this is a formula that converts, it converts Celsius to Fahrenheit. So if you have the Celsius right here, you just plug it in and then you'll spit out the Fahrenheit. Okay. So F will equal 9/5 times -25. That's what they're telling you to do, is plug in this guy, then add 32. So 9/5 times this, that's the same thing as saying 9 times -25 over 5. So break up the -25 there. So that'll be 9 times -5 times 5, right? So this will cancel the 5s. Now I have left 9 times a -5. So that is -45 plus 32. What is -45 plus 32?
Want to be -3?
-13.
13, yeah. Let's see. Let me double check here. Seven. No, that's a lie. Yeah, you're right. I know what I'm talking about. It's 13, man. Seeing things. Okay, so you subtract them like normal, 45 minus 32, and then you keep the sign of the bigger one. So it would be 13, but negative. Anyway. You guys have any questions on anything we talked about today? And you guys understand LCD? So we first started with LCD, but then we added fractions. Then we multiplied fractions and talked about reducing. We divided fractions. Then we moved on to signs, PEMDAS, and we started chapter 1. Any questions about any of those topics?
No, sir.
Okay, so you guys have any issues within Canvas or homework or anything like that? Everything working so far? Everything okay?
Yes, sir.
Yes, sir.
Yes, sir. Not a problem.
Okay, yeah, if you have any issues with it, let me know right away so we can fix it. Then make sure you're already in Remind if you're not already. Set up Remind, so because I'm gonna throw formula sheets in there and random reminders about stuff, announcements, that kind of thing. But anyway, if you guys have no questions, then I'll see you on Thursday.
So are we returning back to campus next week?
Yeah, we'll be back on the 1st, I think. Yeah, the 1st.
Yes, sir. I'll see you on Thursday.
See you Thursday.
Sir, I actually have one question.
Mhm.
So for the week 1 quiz, we have to use the Respondus lockdown browser, correct?
Yeah, I want you to set it up and test it out.
Okay, all right. That's all.
Okay.
Thank you, sir.